Have you ever thought about a force of nature so powerful, so immense, that it actually sets the rhythm of life for more than a billion people? It's like a vast atmospheric river that shows up with almost clockwork precision year after year. And today, we're going to follow that river to understand a much bigger story about our entire planet. So our journey kicks off right here with the Indian monsoon. Just look at this map. It's not just showing a weather pattern. It's showing the very lifeblood of an entire subcontinent. It starts at the southern tip in early June and just sweeps north over the coming weeks. It's predictable, powerful, and absolutely essential. So what exactly is a monsoon? Well, the word itself actually comes from the Arabic word mausim, which means season. And that's the key right there. It's not just a big rainstorm. It's a massive, seasonal reversal of the winds. It's like a giant switch gets flipped in the atmosphere twice a year, completely changing where the weather comes from. Okay, let's dive into that a little bit. How does this giant atmospheric switch actually work? Well, the physics behind it all is surprisingly elegant, really. It all comes down to a super simple principle. Land heats up way faster than water. So, as that intense summer sun just bakes the Indian subcontinent, it creates this huge area of low pressure. And that low pressure acts like a giant natural vacuum, pulling in all the cooler, heavier, moisture-packed air from over the Indian Ocean. Those are the southwest monsoon winds, and when they finally hit land, they just unleash all that moisture as torrential, life-giving rain. All right, now I want you to zoom out with me. That regional engine, the monsoon, it's really just one part of a much, much larger system. We're talking about the engine that regulates the temperature for our entire planet. And that is, of course, the greenhouse effect. This is a great little illustration of how it works. Sunlight comes in, passes through the atmosphere, and warms up the Earth. The Earth then sends that heat radiating back out. But, and this is the important part, some of the gases in our atmosphere act like a planetary blanket, trapping some of that escaping heat and keeping our world warm enough for us to live here. It's a totally natural, totally essential process. Now, the main things that make up this planetary blanket are water vapor, methane, nitrous oxide, and the one we're really going to focus on, carbon dioxide, or CO2. Now, the others definitely play a role, but CO2 is the most abundant of the long-lived greenhouse gases. And that's key. It means it sticks around in the atmosphere for a very, very long time, continuing to make that blanket thicker. For literally hundreds of thousands of years, this system was in a pretty stable balance. The blanket was just the right thickness. So, what's different now? Well, thanks to some incredible science, we can look back in time using ice cores. And what they tell us is that for the last 800,000 years, through ice ages, warm periods, the whole shebang, the average level of CO2 in the air hovered right around 230 parts per million. Think of that as the natural, historical baseline. Okay, now let's fast forward a bit. When scientists started taking really precise modern measurements back in 1958, the level was already up to 315 parts per million. That's a huge jump, already well outside that natural range of the past 800,000 years. And today, we have blown right past 400. In 2019, the reading hit 415 parts per million. To find CO2 levels that high, you'd have to go back more than 3 million years. That's long before modern humans ever walked the Earth. We are in completely uncharted territory. And what's so powerful about this slide is just how clearly it tells the story. That gray line, that's the skyrocketing CO2 we were just talking about. And those red bars, that's the global temperature. The link isn't just a theory, it's right there in the data. More CO2 means a thicker blanket, which means a warmer planet. It's that direct. So, we've looked at this amazing regional climate rhythm, the monsoon, and we've looked at the global heat engine. Now it's time to connect the two. What happens to a predictable, ancient rhythm when you crank up the heat on the entire planet? It really boils down to a simple question of physics. Heat is energy. So when you pump more and more energy into the atmosphere and into the oceans, what are the consequences going to be? So this is the absolute crucial point. Warmer air can hold more moisture, a lot more. And all that extra water vapor in the atmosphere, it's basically like loading extra fuel into a storm system. It doesn't mean you get more rainy days necessarily, but it does mean that when it does rain, the potential for extreme, intense downpours just goes way, way up. And look, this isn't just a theory. We're already seeing this happen. Check out this data from the US Midwest. The frequency of the absolute heaviest, most intense storms, the real flood makers, has jumped by over 50%. The system it's supercharged. And that brings us right back to the monsoon. All that extra energy is messing with its ancient, predictable rhythm. The monsoon is becoming more volatile, more erratic. Its arrival and retreat, much less certain. And instead of that steady, reliable rain, the pattern is shifting to these long, dry spells broken by terrifyingly intense bursts of rain. You get devastating floods in one region, while another part of the country is suffering from drought. The rhythm is breaking down. So, this really takes us to the big picture. The monsoon, for centuries, has been this incredible force that ties a diverse subcontinent together. It's a shared experience. But what does this new reality mean for everyone? This quote from the source material just captures the stakes so perfectly. It's not just about the weather, you see. It's about a unifying bond. The entire rhythm of farming, of festivals, of culture, everything revolves around this one predictable natural event. And so we're left with this big question. A changing climate is disrupting one of humanity's oldest and most vital natural bonds. The rhythm is becoming dangerously erratic, and the consequences are global. The challenge isn't regional anymore. It connects every single one of us. So what's our new unifying response going to be?